Hey everyone, today we are going to start designing a 72 top with a 1384 casting offset, and for that we will use the 3D model and change the box and create a cylinder at offset so that the edge of the cylinder, which is the inside dimension of that casting, from the edge of 7 inches, that's the wall thickness of 72, from the edge. So I'm using a cylinder command over here and trying to snap it to the center first. For before that I will create the inside of the wall so that I know that where I need to place the edge of the cylinder. So now we're going to use a cylinder command to create the cylinder at the edge, and we'll use cyl command to create the cylinder, and then we'll subtract that from the top. And we have the all sizes tops in 3D, and we just manipulate those tops to find out to however we need it. Like if we want to go with for a bigger top, if you guys got a request for an 84 top with a certain opening, like an 18 by 26 opening to be centered offset, or we'll do it like that. So as you can see, I created a cylinder in the center using a cyl command, and now I'm offsetting it, trying to make it offset first to the edge, and then I'll move the dimension to whatever dimension it is to the edge, and then again to the 7 inches offset, so that it is right at the edge of the wall, so that it aligns to the steps. Right, the steps are going to be at the wall, and if someone is entering the manhole, we need to make the opening align to the step. So here the steps are in the wall, and we are offsetting the cylinder. Okay, and then we'll use the subtract command to subtract the cylinder from the top. And I'm creating the circles to find out the cover. So usually we do like 2-inch cover from all the outside edges, and the reinforcement that we show, that we usually draw from like 1-inch cover from the inside face. So not the joint, from the inside face. Okay, so right now what I'm doing is I'm just setting up my AutoCAD the way I like it. Like I like the quick calculator on the left side and the properties on the right side, so that I can work faster and use AutoCAD efficiently. Okay, so now what we're gonna do is we are going to create the rebar layout. Okay, so for that I created the 2D of the top view. As you can see, the red lines are the 2D of the top, and in that I will create the reinforcement line. Okay, we can create the reinforcement in 3D as well using the cylinder command and create the 3D reinforcement, but that's like takes a little bit more time to do it. So I prefer doing it in 2D and 3D. The 3D I do is basically just to calculate the weight of the top and to find out the centroid, so that I can place the lifters along with that, and we'll dig deeper in as we go through the top. So here I took the 2-inch offset from the edges. That's the clear cover of the reinforcement, and now I will draw the reinforcement. So for this top, the reinforcement need to be number 5 on 6. So number 5 rebars on 6-inch center spacing. Okay, so I use the offset command to offset it 2 inches from the edge, and as you can see I have that over there, and the next step will be to draw the reinforcement. Okay, so now you can use the O snap to have all the toggles on, or you can also use the command just like you click the line command and then press the shift and the right click of the mouse, and you will get a drop down menu to snap it to the edge. Okay, so as you can see, So I started from the center and then I snap it on the edge, on the tangent. Okay, so for that you cannot see it in this video, but yeah, what I did is I snap it at the middle of the circle or the edge of the circle, and then I pressed right click and selected tangent from mouse, shift plus right click of the mouse, and you will see the tangent snap, and using that I created those two tangent line from circle, outside the circle. And then now I'm offsetting it 6 inches using the offset command. Okay, as we go you will see that. Okay, and I'm also trying to change the pointer the way I like it. For that I'll usually open the settings. For options, from options you can change the cursor size. I prefer it a little bigger so that I can select the lines properly and work faster. So the narrower the cursor is, I don't like the narrow cursor, because using that cursor I have to zoom in more and select the line one by one, or it takes a little bit more effort for me. So I just like the bigger cursor so that I can click it quickly. And now I'm using the trim command, so I like using TR enter, and then if I need to extend I press shift along with that, so that I can extend and trim at the same time however I want. So as you can see, I created the rebars for that, number 1, 5 and 6, and I'm using the trim command to trim all the rebars, as you can see. So you can also use mirror command, just create the rebar on one side and then just mirror it on the other side. That will be more faster. Okay, so it's just the preference how you want to do it. You want to do it one by one, or you want to do, but the end goal is to how quick we can do it. Okay, so usually I use mirror, or whatever I think of at the moment, I'll just go with that command. So as you can see, I have created the vertical rebars, vertical rebars for this top, for the offset top, and that's how we show the vertical rebars. Okay, like a diagonaling or tangential from the hole. So if the hole was on the center, these rebars will be perfectly straight, not the tangential, just straight, number 6 on 6 on both directions, or whatever the engineer decide. If it's number 6 bars at 6 inches, number 6 bar at 4 inches, or number 6 bar at 10 inches, whatever it is. So now we are creating the horizontal rebars. Okay, so I'm using the same command, TR enter. If I press shift along with the inside the command, it will extend the rebar. Okay, and then I'm using the offset command to offset the rebars. Here it's 6 inches, but it depends on the engineering design. Okay, and I'm using the trim and extend command here. Okay, so as you can see, we are drawing, and I'll show you the mirror command, the way how we can do it using the mirror command as well in short. So this is one method where you just draw each line using trim extend command, and we'll see the other method to do it like using mirror command in a while. So that's how we want to show our rebars. Okay, so I'm going to trim all those rebars so that they are within that 2-inch cover. Okay, and showing cover is important, so that when production sees those rebar, they know that they need to maintain a certain cover. Okay, and in round tops, we usually use a circumferential wire, so that 2-inch offset circle that you see, that's where we will put the circumferential wire. So it's like a vertical wire mesh that you wrap around, and in that wire mesh you place your rebars. Okay, and these rebars are from the inside face, and usually for round tops we will use 1-inch cover from the bottom. Okay. So here I'm using just the trim command and removing all of those. Okay, and yeah, that's it. So now I'll show you the mirror command, how we can do it using mirror. Okay, so you see I selected all the vertical lines, and this is just for you to understand that it can be done quicker if you can think of mirror command. Okay, at the moment, if you don't think of mirror command, then it's just based on how you approach the drawing. Okay, if you see symmetry, you should go with the mirror command and draw it like that. Okay, so that you don't have to do the same thing again and again, and it will save you a lot of time. It's just if you and it also depends like how many drawings you do it. As you draw as much as drawing, you will find a shorter and faster way to do it. Okay, so here's the reinforcement layout that we're gonna have for this top. So here the rebars is number 5 on 6 in both direction, so you don't have to put lot of dimension. You can just write number 6. You can just have when you put the dimension on it, you can just say 6 inches typical. Okay, so now I'm creating. So what happened is you need to provide a diagonal rebars around the opening. So for that, whatever the opening is, you always have to put a diagonal rebar. So here I am putting that, the band bar and the diagonal rebar, since it's a curved top. If you have a space to put like 4 diagonal bars, just like I'm drawing the 2 diagonal bars, then you will put the 2 diagonals bar. Okay, and yeah, like that. So you can either do the band bars or the diagonal bars, but here we don't have a lot of space to put the diagonal bars, so we are just doing the band bar along with the 2 diagonal bars. Okay, so that way we are covering the or reinforcing the opening. Okay, so yeah, so now we are focusing on the circumferential wire. So it's a wire mesh that you wrap around, so that so it's gonna be a straight mesh, right? So it's gonna have a joint, or it's gonna have an overlap, as you see. So here I am putting like it's usually an 8-inch overlap. So yeah, so here I am creating that overlap to show that how the mesh is gonna look like. Okay, so yeah, so it's just a one wire mesh, flat wire mesh that you wrap around. So yeah, you see that. So here I use trim and extend command and the arch command to draw that, right, and offset command. So for the band bar I use the arch command, for this I use the offset command. Okay, and since I already have a line type for that, or already have a layer in which I created this wire mesh, so I'm just gonna use the match command to match the wire mesh layout or line type. Okay, and now I'm trying to create a block of it. I think I missed one rebar, so I'm just gonna extend it to the wire mesh. Okay, yeah, like that. So now I'm gonna select everything except the outside circle. So that's our reinforcement layout. Okay, and I'm gonna create a block of that. So to create the block, I just select everything, then use shift and paste. Control shift, select the base point, or control shift copy to select the base point, and control shift V to paste it, so that it creates a block. And you can use the block command as well to create that. Okay, Yeah. So that's how I did. Now I'm doing a section view of that. So for the section view, I created the rectangle because it's gonna look like a rectangle when you cut a top from the center as section. Okay, and now I'm creating that opening that we have for the casting. So you see that? Yeah. So I use the offset. I create the center line and then offset the radius of that circle so that you can see that offset line. Okay, and then I offsetted 1 inch the rectangle, and then I move it from the edges. It need to be 2 inches, so I move those line to 2 inches. Okay, from the edge, and at the bottom it needs to be 1 inches the cover as per the design, and from the edge is 2 inches. So I'm using offset command or stretch command to do that. Okay, or stretching using the grips of the line. Okay, so that's the rebar that I'm creating. So we are using number 5 on 8, so it's gonna be the height of that is going to be number 5 divided by 8. So that's the height, and the length is going to be that length. Okay, and then I'm gonna fill a hatch, solid hatch in it, so that it looks like a solid rebar. Okay, so after that I'll create the circular rebars, the other section in the other direction, since the bottom one is going to look straight, which is the resisting bar or main reinforcement, and in top of that we'll use the alternate reinforcement or the longitudinal reinforcement, or you can say the reinforcement in other direction. Okay, for that I'll create a circle and put the hatch in it, so that it looks like a section of a rebar, and I create a block of it and then use the array command to create the reinforcement. Okay, so to you do array command, you will press AR enter and it will create a rectangular array. Okay, array command. Okay, so that's our array command. So rectangular array, and we're gonna do is number 6 on 6 inches offset. Okay, or number 5 on 6 inches offset, so that will we have 5 column of those rebars. Okay, and you can verify it from the plan view as well. It should be 5 rebars. Okay, and then I'll use mirror command to have it on the other side of the opening as well. Okay, so here is our rebar layout from the bottom, and from the bottom it has to be 1 inches. Okay, and from the side it has to be 2 inches, and on the sides it's gonna be the circumferential wires, and at the top, since the diagonal rebars need to be at the bottom and at the top to reinforce the opening, so I'm creating 2 rebars on top as well for those diagonal rebars. So that band bar and diagonal knee bar need to be at the bottom of the top and at the top at 1 inch cover. Okay, so I use the explode command to explode the rectangle, and I'm gonna use just the rebar mesh for that, or you say the vertical line is going to be the rebar mesh. Okay, and rebar mesh are usually 2 inches from all sides, clear. Okay, now gonna match the line type, and after that I'll create a block of it as well. So I'm selecting the reinforcement and using Control Shift copy to select the base point, or you can use group command as well to group it. Okay, so here I use group command to group to make all of in one selection, to select everything in one selection. So these are the two methods you can do it. So here I'm adjusting the band bars. I think I offsetted it wrong, so I'm just moving it inside to have it like on 2 inches offset from the edge. Okay, so now it's done. So we have our reinforcement layout, and you can use measure command, MEAS, to measure the distance. Okay, and I adjusted it to have like 2 inches from the edge of the opening. Okay, so here we have our reinforcement layout and there. Okay, so the next option is to have the casting. So for that I'm gonna import the PDF of the casting drawing that we have and create the casting. Okay, so now we're gonna import the PDF. Okay, yeah, so we'll select the file and import this PDF, insert this PDF, and then scale it to be on the same size or to the real life size. So here I'm scaling it using SC enter command and then using the reference R to select the dimension that I know of. So that dimension need to be 23.5, so I just enter the new length to 23.5 and scale it like that. Okay, and then I'm gonna delete everything that's not required, like dimensions, all the dimension or all the unnecessary data from the PDF. Okay, so that is the section of cover. So, and I'll create a block of that using Control Shift copy or Control Shift C, and then select the base point and then Control Shift V to create a block of it. Okay, next so that's the cover, and next we're gonna do the ring. We'll do both the section and the plan view of the ring. So here's the ring. I use the same insert PDF, selected the PDF and imported it in here. Okay, so now I scale it to the dimension that I know of, so that need to be 22 inches. So I scale it to 22 inches using the scale command and then using R reference in that one. And now I'm deleting all the unnecessary ledger or arrows or dimensions that I don't want in my drawing. And now I'm gonna create the block of it using the same command, Control Shift copy C and Control Shift V for both the section and the plan view of the ring. Okay, and I think I missed the cover as well. So after doing this, I'm gonna import the cover drawing again and have the plan view of the cover. So that's the plan view and the section of the ring. The next thing we're gonna do is to have the plan view of the cover. Okay, So yeah, and also this is a reversible ring. So for reversible ring we usually try to do the flanges on top. Okay, and now I just place the section of that cover on top of the section of the ring. So that's how it's gonna look like. So that's the section of the ring and the cover together. And now I'm gonna import the cover plan view, which I missed when I imported it earlier. Okay, so yeah, here I'm gonna delete all the unnecessary things except the cover. We already have the section, so I don't need it anymore. And I'm gonna delete the ledgers, all the arrows and all the text that are not necessary. Okay, yeah. And using the same command, Control Shift V. So for that I have to scale it as well. So I'm just doing the undo command because I forgot to scale the plan view. So I'm gonna go back to the time where I have the dimension of that, have some dimension to scale it, and then I'll create a plan view of that one. So now first I'll have to scale it and then delete the unnecessary things. So yeah, so I'll scale it to 23.5, which is using the scale command and then reference in that one, reference command to scale the particular line that we already know the dimension of. And then again back to removing all the unnecessary things from it. Yeah, so as you can see we have the plan of casting and the casting together. Okay, so we have the casting and we have the reinforcement layout and we have the top. Okay, so now so this is the layout that we use for all our top drawing, which has the plan view and the section view or the side elevation, whatever you want to call it. Okay, so I already have those templates, so I just use build upon those templates. So I just use the top drawing from past project and just manipulate it and update it like that. Okay, so yeah, so that's our layout. So next we're gonna do is create the layout. Okay, so in the layout we'll go to the layout option at the top, then select the base. Okay, and then we'll go to the model space and select our top. Okay, so that's 70 top, that's what we're gonna select, and then select the top and select the proper scale, and then yeah, place the top view and then just drag it to create the section view. So here you have your top. Okay, yeah. So next step, we're gonna put the hatch or casting. So we're gonna Control Shift C, copy, and Control V, not Control Shift V. Control Shift V create the block. So we just paste Control V, so that will just paste the object. Okay, so now we're gonna scale it. So that's the inside dimension, or that's our opening at the bottom of the concrete, right? So we're gonna scale it to that size using scale SC, enter scale command, and in that command we'll type R for the reference. Okay, and then we'll just move the casting to its proper position. Okay, yeah, so just drag it and match it to the top. So that's how we have the casting. Okay, so the next step would be to create the reinforcement. Or the dimension. Okay, so as you can see, the dimension is 4 by 4 inches. That's not true, that's the paper scale dimension. But you see 19 inches, that's the actual dimension of that length. So for round openings we always do it to the center. Okay, the center location. And the 4.5 inches that was showing earlier, that was because it was taking the paper scale dimension. But when you draw the actual dimension or just select the proper lines, just like that 15 inches, it will give you the proper dimension. Then you can use match command, MA enter, to match the dimension that are not for related to that particular scale, the way I did it for the other dimension, and just like the way I changed the dimension 4.5 to 67, or these 43 or 43. Next we'll select the scale, so we'll go into that and we'll double click that, and then it will pop up a window in which we'll select the object. Okay, in object we'll select the custom view, and then custom view we'll select that, and in that we'll select the dimension. Okay, so right now it's not showing that view, maybe because of the recording, but yeah, so when you double click it, it will pop up a window, which will I show you in a PDF slide, or when we do the meeting, in that I'll show you how I did that. Okay, yeah, now we're gonna place the reinforcement. So Control Shift C, copy, and then Control Shift plus paste here. So yeah, we're gonna scale this as well to match the scale of our plan. Okay, so we'll just SC enter, then R enter, reference, and yeah, select the width of the top. And here it is. So we're just gonna move that rebar cage to its proper location. So that's our rebar layout, and the next we're gonna do is move the rebar. So when you copy and paste it, the group from one space to another, like from model space to the layout space, it will ungroup it automatically, but it doesn't do that for the block. So that's why I usually prefer creating a block. But yeah, so if you do that, then you might have to regroup it and then move it to its proper location like that. Okay, so yeah, so that's the tag for casting. We're gonna update the actual name, it's not V4275, so in a while we'll change that. So right now we are editing the block. So we want to show the diagonal bar which is different than those bar, or not in the size, but we want to highlight those. So what I'm gonna do is I'm gonna change the thickness of that polyline. Okay, so there are the line width of that line from the properties. So yeah, as you can see, I changed the line width from the properties, so those lines look like a little thicker. So that's where the production guys can differentiate between the lines, or can see like those 3 additional lines that we have to put to make it drawing more clearer. Okay, so this is a template that I have. From that I just use to just copy those stuffs and reuse them in my other drawings. So I'm just copying the things that I'm gonna need in that drawing, like the cut list and the tags. So in all the drawing we need to create a cut list to our bar bending schedule of all the rebars. So right now these the main reinforcement. So here we don't have 2 mats. So whenever we have a no bottom lip, so in tops we have 3 joints, the regular manhole joint, no bottom lip, which means no joint at the bottom, and then the recess joint. So whenever we have a no bottom lip and round tops, we need to provide two mats. Okay, and the engineer will provide you with what size and what spacing. So rearranging tags. Okay, so here we just have 1 mat, so I'm just gonna remove that top mat tag, and we just gonna have a bottom mat with number 5 on 6 off center and 1 inch clear. Okay, yeah, and I'm just gonna copy that and put that tab for the plan view as well. So yeah, so for dimension I usually use dim command to just snap the lines and create a dimension. But yeah, you can use dim enter linear dimension or a line dimension, or yeah, but I usually do as much as with dim and quickly create all dimension. So now I'm gonna move everything to a little side so that I have enough space to put that cut list table over there. Okay, yeah, and rearrange dimensions to be within the border. Move, so that tag is for the manhole joint, so the inside face is that dotted line, so that's the inside face of the top, and the bottom line dark line that you're seeing, that's the lip going all around. And I'm just gonna drag the rebar mesh to the joint because it's gonna go through the joint to the top, like that, and usually it's like 2 inch clear from top and bottom. And that's the tag for that mesh, the size of that mesh. Okay, and I'm gonna update the area. So engineer is gonna provide you that area. Usually it's fixed for each top size, so that 0.15 I guess that's for 60 top, for 70 top 2 top it's different, and I'm gonna show you in a while. So yeah, we don't need that tag. Okay, so next I'm gonna do is so here we gonna need the tags for the length of rebars for each rebar that we need to cut, and then those tags we're gonna put in the cut list table to create the complete table with the actual length of the rebar that the production guys need to cut to produce this top. Okay, and they need to follow the drawing that we're gonna provide. Okay, so how we create the reinforcement diagram is going to govern or is how the production guy is gonna follow the construction. So here I got the tag for the reinforcement, and I'm gonna place those tags to each reinforcement or to each reinforcement that is different, okay, in size. So since, as you remember, I mirrored those rebar, right? So those are of same length. So for those, I'm just gonna put a tag to one, and I think it's pretty obvious for production to understand that they need to use the same rebar size on the other side. So I'm just using copying command, and then I'm gonna change the tag number starting from 1. Yeah, so we're gonna rename those tags, and we'll create more tags for all the horizontal and vertical. Okay. Yeah. I'm just creating the tags for all the rebars. And I'm gonna place the quantities of those rebars in the bar bending table, so that production knows that we need to cut 2 of those bar, and they're gonna use that over here. So if they are like the 2 rebars with same length, so they're gonna have those 2 rebars, right? So when they read the drawing, they know that this is like 2 same size rebar, and then I'm gonna place those rebar at the correct location. And right now I'm just using copy co enter copy command for all of it. Since these are like special rebars that are not like number 516 or something, these are like diagonal rebars, so I'm just gonna place a tag or description that they have to use number 5 diagonal rebars and a band bar, since one of them is a band, so diagonal and band bars. Okay, top and bottom, so those need to be at the top and at the bottom to reinforce the opening. Okay. Then I'm gonna rename the tags. And put a typical dimension. So since here all the rebars of the same spacing, number 6, right? So I'm just gonna put number 6 inches, and now it's understood for production that they have to place everything at 6 inches vertically and horizontally. And I'm gonna add another dimension for the horizontal one as well to be more clear. And usually I add typical TYP dot along with the spacing so that they know that that's typical. So they have to place all the rebars at 6 inches. And I'm gonna rename all the tags. And sometimes when you do the round or square tops, the spacing are not even, okay, or maybe you have double mat. So in that case, you will show the reinforcement layout of the bottom mat in the plan view, and then you will show just in section view, you will show 2 mats to specify that there are double mats. And as we put the note that number 516 off center for the bottom mat, we're going to put just the same note for the top mat, but we won't show that since sometime it happens that the top mat is number 5 on 12 inches off center and the bottom mat is number 5 on 6 off center. So those are different spacing, and you cannot show both the spacing in one drawing. Okay, so either we have to create 2 plan views that will show one for the top for the bottom mat and one for the top mat. That's the one option that we can do to be more precise and more detailed. Here I don't have double mat, so I just did the one drawing. But yeah, if we have double mat, we can just create 2 different drawings or 2 plan views. One plan view showing the bottom mat spacing and reinforcement layout, and the other plan view will show the different spacing or top rebar layout. Okay, but in case the top and bottom both mats are the same size and same spacing, then you don't need to show 2 different plan views, just one plan view and just adding a note that top and bottom mat number 516, number 516. That should be more than enough. So here we have renamed the tags. The next we have to update that rebar cut list. So for that, since it's an OLE object, I have to open it to edit it. So I'm gonna use command OLE, OPE and open. So when I click that, it will open an Excel file, and I'll show you in a while that how we can do that. So I usually put that Excel sheet that I opened using OLE open command. I'll put them side by side, and then I'll use the measure command to measure the line segment. So if you measure it over here, it's not gonna give you the correct dimensions, since those are like 2D lines. It's not a part of a 3D object. If it was a part of 3D object and we have created all the rebars in 3D using cylinder, then when you measure it, it might give you the exact dimension, right? Or if you match that dimension with the actual scale dimension, then it might give you. But the easiest way that I think is to do it is to create another layout and then create a viewport in it, right? Since you have the actual dimension or actual scaled rebar layout in the model view. You just create a model view and create a viewport in a layout, and then just add dimensions to those rebar using dim command. And always used when you click dim and press the shift, it will give you align dimensions. Okay, and you just put those dimensions over there, and simultaneously you can just fill those dimensions in the Excel sheet that you have for the bar cut list. Okay, so here I'm just adding the dimensions to the vertical bars, and then I'm gonna do the same for the horizontal bars. And I'm using a command dim enter, and then just selecting the line and pressing the shift key to have the dimension created as align dimension, not the linear one. So that will give you the exact length of the rebar. Okay. And I'm just checking the bar number, since if I am putting the length simultaneously in the Excel sheet, I will have to match I will need to know the tags, right, of that dimension. So like for number 7 bar, for the 7 tag bar, the dimension is that I need to confirm. And here I missed one dimension, one rebar, so I'm just gonna add a tag to it and just put that at the end in my cut list. And similarly I'll put the dimension for the other tags as well. Using the same dim command. I'm just doing the same thing for all the rebars and then adding those dimensions into the Excel sheet. So here we have all the dimension of the rebars. Okay, and I'm simultaneously added those dimensions to the cut list, the Excel file. Okay, so that I don't miss any rebar. And our diagonal rebars are like 55 inches, so I like to do it like 1.5 times the length of the opening, or 2.5. Okay, 2.5. So if you have 24-inch opening, we'll just put 5 feet rebar, diagonal rebar approximately. Here I have used 55 inches, so anywhere between 2 to 2.5 is okay. So since I updated those simultaneously in the Excel sheet, I'll have to copy the table the table in the cut sheet Excel file and paste it again, because the previous cut list has a certain selection which is smaller than the current table. Since our current table is big, so we need to place it again. So just select the table, Control C copy, come back to AutoCAD and Control V paste, and you will have the same table. Okay, and just make sure you select the table, go to the properties and change it to the high resolution and properties. So when you select the table and go to the properties, you will see an option at the bottom, monochrome, visibility, or high resolution or low resolution. So you'll select high resolution, because if you select monochrome or if you don't change it, the table will be printed in black, and we don't want to do that. So here's your top drawing with the table and with other dimension. So here the Excel sheet that will open up when you click overlay open command. Okay, and you will have to modify that list. Okay, so right now I've created two lists for top mat and bottom mat, but here we just have one mat, so we're just not gonna specify two mats, and we're just gonna remove that. Okay, and we'll add multiple columns. So here, as you can see in the tag, we have almost 21 different length rebars, so we'll have to create 21. Okay, so I'm just gonna add more lines to it in Excel, drag it to the bottom, and change the bar size to 5 and just drag it to the bottom. And we have to update the quantities for now, just put 111, drag it, and then we'll update it as we go. I deleted the length since we need to fill that up. So next we're gonna do is we need to put lifters in it, so that production know where they have to place the lifters. And here we updated the rebar, the wire mesh. So for 72 the wire mesh is 0.18, and we need to update that. And then in the rebar notes, or in the notes, we're gonna remove the rebar notes since we already showed the rebars. So instead of those notes, we're gonna put reinforcement as shown. Okay, so that's what we're gonna do. Reinforcement as shown, and production just can refer to the diagram and place the reinforcement accordingly. Okay, and usually when an engineer gives you the detail, you have to update the loading from HS20 to traffic or pedestrian or whatever you specify with earth fill. Here we have no earth fill, but usually it can be 18 inches or 20 feet or whatever it is. Okay, and the compressive strength also changes. And for here we are updating the casting. So this casting is V1384 and ring and cover. So we have to update that based on whatever casting that we are using. It can be a casting or it can be a hatch. Then I'm gonna add an additional dimension for cover. So here we have 1 inch cover, but since the line drawn on a 3D object is just showing 0 to the scale of the paper. right? So we need to match the scale of that dimension to the scale of our drawing. So when we match it, it will show 1 inches, which is the actual scale at 3/4 of 1 feet scale. Okay, the same thing we're gonna put other dimension. So here saying 1/4 inches, that's the paper dimension, and we're gonna match it to the drawing dimension, and it's 2 inches. Okay, yeah. So those details we need to provide. We need to always specify the cover based on whatever the engineer is recommended. For round top, it usually 1 inches, but it depends on different plants. So if some top are produced in Florida for the Florida section, then it might be 2-inch cover instead of 1 inch. So it depends. So engineer will let you know what cover that you need to use or how you need to draw. Okay. So next we're gonna use a mask command, MASS, and it will open up a table, or not table, or detail, or you say the volume and everything at the bottom. Okay, and from that you will copy the volume text, and then so that is in inches, so you have to use the quick calculator that which I usually prefer to have it on the side, and then divide it by 12, divide by 12 into 12 into 12, convert it into feet, and then multiply it with 150 cubic feet. That's the unit weight of concrete, and then divide by 2000 to convert into tons. Okay, so you will use the mask command, copy the volume. Okay, so whatever the number that you get in front of the volume, copy that, paste it into the calculator, and then divide that number by 12 by 12 by 12 3 times. Okay, to convert it into the feet, because that's the volume in inches, and then you multiply it by 150 to, because 150 is unit weight of concrete, and then you divide it by 2000 to convert that value that you got in pound to convert it into ton, convert it into in ton. Okay, and then at the title block you'll change the name to 72 top with V138 forecast in offset with 9 inch. Okay, so that's the description of the top. Yeah, you will have to update the job number as well in that title block, and usually we can have it as a blank so that we can use the same top for different jobs, but I used to keep the job number over there, so in case we need to use the same top for the other job, we can just edit it out. Okay, and yeah, I do it the job number because I have the CAD file, and I can just go and search for the CAD file based on the job number, because I place all my CAD files per the job numbers or job folders. Next is going to be lifter locations. Okay, so for that also I'm gonna use the mask command, MASS. It will again open the dialog box or description from the bottom. So in that description you will copy the coordinates for centroid. So you will see a centroid coordinates minus this, comma minus this, comma minus 3 x y z coordinate. So you'll copy that and then paste it in Word or Notepad, wherever you like, and then sequence it. So you will have, if you are getting x y z coordinate, you will put it like x comma y comma z, the actual number instead of x y z. Okay, So we'll put x coordinate, comma y coordinate, comma z coordinate. Okay. And when you use PO enter point command, okay, PO enter, and then put that coordinate in sequence over there, and then enter, then you'll see that point created over there. Okay, so the sequence is using mask command. Copy the centroid XYZ coordinate, put them in a line in a notepad, copy them, and then click the PO enter point command, and then just paste the coordinates in the point command, and it will create a point at that location. So that will be your centroid. Okay, and then you will just move the circle or create a circle and put that at the centroid. And you can select the point visibility or looks using p-type command. p-type enter command and change the pointer location. I usually use that location, that kind of pointer, for if I have a detailed rebar then. Okay, so right now I'm doing is, so for 70 tops we use 3 lifters. Okay, so and usually we put it at 1.5 times the slab thickness. So if slab is 9 inch thick, I'll put it at 18 inches if possible. If not, then minimum the slab thickness, 9 inches slab, 9 inch offset. That's the minimum. But as long as possible, just do it 1.5 times the slab thickness. So that offset. And from centroid we need 3 lifters. So I'll just create 3 lines or divide that circle in 3 equal parts using the rotate command. I'll just create 1 line and rotate that 120 degree and then 120 degree again. So now I'm just create a block of that, Control C copy and Control V paste. Okay, so that's the block. And yeah, as you can see, I have offsetted 9 inches from the opening circle as well, so that I see it's not within that range, the lifter. So it has to be 9 inches or whatever the length is from the outside edges of the top, and also from the opening. And now I'm creating the points at that locations, and then I'm gonna move those points using move command. And so before that I used scale command to scale that drawing to the same scale, and now I'm moving the lifter or points to my reinforcement drawing. And now I'm gonna add the dimension to it, and I'm gonna just change the look of dimension so that it looks different than the other dimension, so that production can identify that that dimension is for the lifter only. Okay, so usually I put horizontal and vertical border dimension, but this lifter is from the center, so there is no need for the horizontal dimension. Vertical should be good enough. But I'm going to change the line type to hidden line so that it looks different than the top dimensions. Okay, and for the other lifter I'm gonna put the horizontal and vertical both dimensions, because that is how production gonna place it, and they're gonna need 2 dimension to place it at the exact location. And I'm gonna match it to the other dimension, and always make sure that the dimension that you are placing is to the scale, and if they are not, then use match command to match it to the dimension that is already to the scale. So yeah, here we have horizontal and vertical dimension. for those two lifters. Okay, and that's for the top lifter. So now we have the lifter locations. Okay, recheck everything so that everything is within the boundaries of our drawing. Okay, and just see that the lines are not crisscrossing. And for the lifters, we need to add a note stating the capacity of the lifter. Okay, so if you are using 3 lifter, you will divide the weight of the top by 2. Okay, so 3 lifter, you will divide the weight of the top by 2. If you were using 4 lifter and the square top or maybe a big round top, then you will divide it by 3. So here we have to divide the weight of the top by 2, since we are using only 3 lifters. Okay, so yeah, so in the notes for the lifter we'll say 3 lifters at whatever our weight is. So the weight is 2.35 divided by 2. Okay, so and that's going to be our lifter capacity. So 2.35 divided by 2, that is 1.20 approximately capacity each. Okay, so that's the capacity of each lifter, so that we are covered with any excess load or unintentional loads during lifting of the top. Okay, and we'll just move the dimension little away so that it doesn't cross the ladder of lifter weight or any other, and make it little clean. Okay, so yeah, here's the top drawing, a 70 top with the casting offset, with the rebars, and with the cut list. So usually we do plan view and section view. Okay, and we try to have as much as information as possible in this top drawings. Okay, and that's the typical top drawing that we do for the round tops. And for square and rectangle, it's similar, nothing drastically different for those. For the square top also, we're gonna create the same rebar, reinforcement and everything. Okay, and yeah, so mostly we'll do plan view and side view unless we have a double mat. So in double mat we need to create 2 views. So for that we'll have to use a landscape layout instead of this portrait layout, so that we can have 2 views on one page. Okay, yeah, that's it.